This is question number 16 from the 4.1 and 4.2 MyLab math homework that included the idea of the point of diminishing returns. Now, a student emailed me to ask about this question, so I'm going to focus in on this part right here. How do we find the maximum rate of change of t-shirt production? Okay, but first let's read the problem and just kind of talk about the overview, the big ideas leading up to this question. So we're told a t-shirt manufacturer is planning to expand its workforce. It estimates that the number of t-shirts produced by hiring X new workers is given by this function over this domain. Okay, so remember, before we go any further, the point of diminishing returns is finding that sweet spot, finding out where you get the most bang for your buck. So here, they're investing money in hiring new employees. And for a while, as I hire new employees, it's going to increase their production, right? But then that production, it's going to increase faster and faster for a while, but then it's going to start to taper off. So we're trying to find that sweet spot, that number of employees that they can hire that will really maximize the production of t-shirts here. So we're being asked, when is the rate of change of t-shirts production increasing and when is it decreasing? Then we're being asked, what is the point of diminishing returns? And here's the question that I was asked, the maximum rate of change for t-shirt production. Then we're asked to graph t and t prime on the same coordinate plane. I won't ask you that on a test. So if you need to use Desmos for that part, that's fine. But let's talk about this. So whenever you start any problem with a function, slow your brain down and ask, okay, what is the input and output of this function, right? So let's start there. Okay, so we are told that X, our input, is the number of new workers they hire. And we're calculating the number of t-shirts that get produced when we hire X workers. And then our domain tells us they are willing to hire between 0 and 27 workers. Okay, so if I find t prime, if I find the first derivative, that's the rate of change of t-shirt production. That's how t-shirt production is changing with each new employee that's hired. Okay, and if I take the derivative of that, t double prime is describes the concavity of the original function, right? That's not as helpful in this situation. T double prime is describing how t prime is changing. It's the rate of change of t prime. So t double prime is describing how the rate of change of production, production is changing. So it's describing how t prime is changing. So let's find both of those real quick. Okay, so I just did some quick power rule to find the first derivative and the second derivative. And then the point of diminishing returns focuses in on this second derivative. It's about how the rate of change is changing. So we're just going to find that inflection point. The point of diminishing returns happens when we change from concave up to concave down. And that's our inflection point. So if we just set this second derivative equal to 0, and then we solve for x, that's going to give us our inflection point. So we're going ahead, set that equal to 0. We factor that out, and voila, when you're done, you technically get 2 candidates for inflection points, but we're not going to consider the first one, x equals 0, because the point of diminishing returns happens when we change from concave up to concave down. And we can't look to the left of x equals 0 because that would not be in this domain. X is our lower limit on the number of employees we can hire. Okay, so our only candidate there, number 18, that's going to be your point of diminishing returns. Okay, so I've labeled here on the graph, this little graph that I sketched right there, this is of the original function. So this is of t of x. And that point of diminishing returns, that's where the second derivative is 0, and that's happening when x is 18. Okay, so that's your point of diminishing returns right there. That's where I'm going to switch from concave up to concave down, but we need to confirm that. So you'll actually create your second derivative sign chart just to confirm that we're changing from concave up to concave down at that point. And to save some time here, because I know you can all do test points on your own, I'll go ahead and just confirm that that is true. It's going to change from concave up to concave down there. And so what's happening with this second question about how exactly was it worded? Let me pop up here. To find the maximum rate of change for t-shirt production. So the rate of change, that's just T prime. If I want to know the maximum rate of change, I'm going to think about the tangent lines on this graph. So I can see that this tangent line starts off pretty horizontal, right? So this is the rate of change, the tangent line is describing the slope of T, of graph T here. And then as I move closer to my point of diminishing returns, I can see that tangent line is getting steeper and steeper and steeper, and the steepest it'll ever be is right there at that point of diminishing returns. And then my tangent lines start leveling off again. Okay, so T prime is increasing. The slope is increasing. It's increasing, it's increasing, it's increasing, and it's maxing out. That rate of change, that slope, is the steepest it'll ever be at that point of diminishing returns. So if I want to know the maximum rate of change, I'm going to take that point of diminishing returns when x was 18, and I'm going to plug it in to the first derivative to calculate the slope of that tangent line, to calculate that rate of change, that steepest point on the graph. And that'll be my maximum rate of change of the function. So I'm going to plug 18 back into T prime and see what I get here. Okay, so when I plugged it in, I got an output of 5,832. But we need to think about our units. So remember, a derivative is a slope. It's a rate of change, right? It's your change in your outputs over the change in the inputs. So we need to think about our units for that. Okay, we were inputting what? Yep, we are inputting the number of employees, right? My input was the number of employees that were being hired. And we were calculating, that's your output. You were calculating the number of t-shirts being produced. So when you go back to interpret this derivative, I'm going to put it over a 1. I'm going to put my output over a 1 so I can see that change in the outputs over the change in the inputs. And I'm going to use my units there. The outputs were the number of t-shirts being produced. So that'll be my unit for the numerator. And the unit on the input was number of employees hired. So I can see my maximum rate of change there. If I hire 18 employees, I'll experience a maximum rate of change of 5,832 t-shirts being produced for each additional employee being hired.